Percentages are popular ways of expressing fractions. Let's open our TM and look at some interesting relations in percentages. Did you know that 10% of 10 equals 1? You don't need to do any lengthy calculation. You just multiply 1 by itself and you are done. 20% of 20, same, 2 times 2, that gives you 4. So what will 30% of 30 be? Obviously, that's 9, and it follows. Did you know that 10% of 20 equals 2? Here you have 2-digit numbers, both end with 0. So you just multiply the first digits, 1 times 2, and you have 2. Similarly, 20% of 30 equals 6. It follows like that. Did you know that x% of y equals y% of x? 10% of 20 equals 20% of 10. 10% of 35 equals 35% of 10. 1% of 100 equals 100% of 1. Now, if a quantity Q is increased by A%, the result increased by B%, what is the effective percentage change in Q? This is given by A plus B plus a fraction with numerator AB, denominator 100, that's some percent. Let's look at an example. A quantity is increased by 10% and the result is also increased by 20%. By what percentage has the original quantity been increased now? Substituting into the formula I've given you, you have 32%. In a similar vein, if a quantity is decreased by A%, the result decreased by B%. The effective percentage decrease in Q is given by A plus B minus AB over 100, that difference percent. For example, a quantity is decreased by 50% and the result is decreased by 20%. By what percentage has the original quantity been decreased now? Again, if you substitute into the given formula, you have 60%. Here's yet another one. The cost price of 10 pence is the selling price of 8 pence. If each pen cost the same amount, find the profit percent. You find that this is simply 10 minus 8. That on 8 times 100%, you have 25%. In general, if the cost price of X identical objects is the selling price of Y objects, the profit percent is given by a fraction with numerator 100 multiplying the difference between X and Y. That's X minus Y. Denominator Y percent. Another one. If a quantity Q is increased by A%, by what percent must the result be decreased to get back to the original quantity? So assume you have 1,000 and you increase by 20%. That will give you 1,200. The problem here is by what percentage must you decrease this 1,200 to get back the 1,000? Will it be more or less than the 20? Obviously, it won't be the 20. These are the smallest of the issues that thinking mathematics has addressed.